In this section, we will talk about imaginary unit and complex number. However, for this class, we only look at the imaginary unit. As in our previous section, we cannot really simplify the square root of a minus number, for example, minus 9, because we cannot find a real number that can solve this problem. So really we looking for, so there's no real number, right? But when we extend our number system and we call it a complex number, and to define a complex number, you will learn later on when you go to 1105. But for this class, we just want to define what is meant by the imaginary units. We say that xi squared is equal to minus 1, and therefore, when you take a square root to both sides, I equal to minus 1. So we actually, I is called the imaginary unit, and we define that equal to a minus 1. So now from here, we can allow us to simplify the square root of a minus number. But please keep in mind, this is only work when we deal with a complex number. Alright. Usually when we ask you to solve a problem with our statement, with our deduction, we mean we want to look at in a real number. But for this section here, we look at the number called a complex number, and I is a part of the imaginary unit, and it's a part of the complex number. So more detail you will learn from MAT 1105. So if you want to simplify the square root of minus 25, we can rewrite as 25 is 25 times minus 1. Now I'm using the rule say that the square root of a times b equal to the square root of a times the square root of b. So therefore, our problem here can rewrite as the square root of 25 times the square root of minus 1. The square root of 25 is 5. And we define that the square root of minus 1 is I. So our answer is 5i. It's actually the imaginary unit. In this case, we have a complex number. 5i is called a complex number. Let's look at this problem, and we can do the same thing here. We can view this as 32 times minus 1, and rewrite this as 32 times the square root of 32 times the square root of minus 1. Now 32 is 2 times 16. Now 16 is the perfect square, so we have 4 coming out, and the 2 is our remainder. And then this is equal to I, so we put I. By standard, we put I in the front. In the front of the radical. Try next one. Next one, we can rewrite this as a minus the square root of 121 times minus 1. So I have minus the square root of 121 times the square root of minus 1. The square root of 121 is 11. This minus sign here I carry down. And the square root of a minus 1 is just I. So to be more simple, if you work with the square root of minus 9, all you have to do is take a square root of 9 is 3, and then you put I there because you have minus inside. If we work in the complex number, so you don't have to go this long process. So you can look at a more example if you want to find the square root of minus 64. We know the square root of 64 is 8. Because I have minus there, doesn't mean I have a complex number, so you put an I. That's it. This is all for section 10.7.